Calorimeter, the topic for biomedical instrumentation, which will be available in the Unit 5. Calorimeter. Okay, meter means going to measure some of the things. Okay, meter there have many of the types. Okay, analog meter, digital meter, or using ultrasound meter or frequency meter, like that. Many other types are having. Meter means generally we are going to measure uh, any type of uh, the variable called as a meter. Here using calorimeter. Calorie means generally we have say calorie, CLORI, which is here COLORI. Calorie means for energy we can calculate the calorie. Here we are using color, how the signal is absorbing, like that calorimeter will be here. Okay, calorimeter. Calorimeter is a light sensitive device. Sensitive. Sense means normally we know sensor means sensitivity will be sure. Okay, sense will be created from the human sense. Okay, for human being, six sensors have. So sensors also available only six types alone. In any sensor, the name will be different, but the sense means six sense only available in all over the world. So here is a light sensitivity device. Okay, the basic or very important topic for sensor is a sensitivity and selectivity. Okay, we want to select particular value and sense a correct value. This is a very important for sensor. So here we are seeing the light sensitivity device. So we are going to sense the light used for measuring the transmittance and absorbance of light passing through a liquid sample. Transmittance means we are transmit a signal from one place to other place, and absorb means the place, the medium will be absorbed some of the signal, which will be passing by the light. Okay, the light passing through the liquid is a sample for us. So for by the liquid only we can check whether the light sensitive device is working properly or not, or it will show the correct chemical values or not. We can check using the light sensitivity device. The device measures the intensity or concentration of the color. Okay, concentration means how much, suppose light color, dull color, or over concentration is there. Like this, we have seen, like that the concentration of the color or intensity of the color that develops upon the introducing a specific reagent into a solution. Okay, a calorimeter involves the measurement of color, and is a widely used method for finding the concentration of biochemical compounds. Wherever we want to identify chemical activities or what are the components present in the chemical means, normally or generally we are using the calorimeter technique. Okay, it will be used in biochemistry, microbiology lab, and for some other labs. Also, we are using this calorimetry method. Okay, it measures absorbance and wavelength between 400 to 700 nanometer. Okay, it measures the absorbance. It is a very important point. Absorbance is the wavelength between 400 to 700 nanometer. The 400 to 700 is the visible spectrum of light. Okay, this is our visible region, so that only we can see any of the things. If we want to see a pen or car or any other thing, it will the object will be should our object should have in the range of 400 to 700 nanometer only. So this is a electromagnetic spectrum. Okay, electromagnetic means electrical signals also that, and magnetic signals also that. Spectrum means the group of signals will be called as a spectrum. Okay, absorption of light. Okay, light falling on a colored solution. You are having one solution which is in a colored state. So the light will be falling on a colored solution now. Is either absorbed or transmitted. Two things are will be happen when the light will be passes in any places. One is absorbed, or otherwise it should be transmitted. Okay, here absorption of light. So the liquid will be, or the solution will be absorb the light. A colored solution absorbs all the colors of white light, and selectively transmits only one color. This is one color. This is a one color. Okay, this is a very important point. It transmits only the one color, and also it is a one color. Okay, the basic principle for colorimeter is work on the photometric technique. It states that when a beam of incident of light intensity, for intensity of light is I naught, which means the starting place of the light. Okay, that is called as the intensity I naught passes through a solution. A part of incident light is reflected, IR. Here IR means reflected portion. A part is observed. Observed portion is A. And the rest of the light is transmitted. Transmitted light is mentioned by IT. T is a transmitter. So if you want to calculate the light intensity means I naught. I naught is the light intensity. And other intensities are how it is calculated means IR. IR means reflector light and observed light intensity and transmitter light intensity. When we add these three terms, which means reflected, observed and transmitted means the basic light intensity will be we can get. Okay. In calorimeter, IR is eliminated because the measurement of I naught and IT is sufficient to determine the IA. So we never consider the IR. Okay. This is the fundamental laws we are using in the calorimeter technique. First one is Beer's law. This law states that the amount of light observed is directly proportional to the concentration of the solid in the solution. There have formula log 10 I naught by IT. I naught means intensity of light divided by IT. IT means the transmittant, अर्थात intensity of light transmitted equal to AS into C. AS is absorbency index and C is the concentration of solution. This is the basic principle using in the calorimeter. And another one principle is also using in this calorimeter, that is Lambert's law. Lambert's law. The Lambert's law states that amount of light observed is directly proportional to the length and thickness of the solution. Okay, length and thickness of the solution. Previous law, Beer's law states that the amount of light observed is directly proportional to the concentration of the solution. And here directly proportional to the length and thickness of the solution under the analysis. So here the formula is A equal to log 10 I naught by IT equal to AS into B. So A is the absorbance test, AS means absorbance of standard and B is the length divided or thickness of the solution. Okay, this is the difference between two laws also, Beer's law and Lambert's law. Both the laws are used in the calorimeter technique. Okay, in first technique means we are using the light is observed directly proportional to the concentration of the solution, and second one is to calculate the length and thickness of the solution we are using. Okay, here some of the mathematical representation used in Beer-Lambert's law. Okay, log 10 I naught by IT equal to AS into BC. Okay, if B is kept constant by applying covered or standard cell, then the value or the formula will be changes to log 10 I naught by IT equal to AS into C. Okay, and the absorbance index as is defined as AS A divided by CL. C is a concentration and L is a distance in travel by the light in solution. See, below they are mentioning C equal to concentration of absorbing material in gram per liter and L equal to distance in traveled by the light in solution in centimeter. Okay, this is the simplified form for Beer and Lambert's law. Okay, the absorbance of light is directly proportional to the concentration of solution into path length, which is mentioned as A directly proportional to C into N. A is the absorbance optical density of solution. C is the concentration of solution. L is the path length. Okay, A generally for remove the directly proportional, A equal to epsilon into CL. Epsilon is equal to absorbance coefficient. Okay. Types. Color densitometer, which is used to measure the density of primary color, which means the important colors or the first type of color. Okay, is used in the primary color. Second one is color photometer, which measures the color reflection and transmission. So the types in colorimeter means there are only two types. One is color densitometer and another one is color photometer. Color densitometer is used to measure the density of primary colors and color photometer is used to measure the reflection and transmission level of the color. Okay. The design of colorimeter. Okay, how to design a colorimeter means there are some of the parts in the colorimeter. First we need a light source. Second, monochromatum. Third one, sample holder. Fourth one, photo detector system. Fifth one is a measuring device. Okay, light source, maybe a candle or some of the battery type light sources. We can use it here, light source. The most common source of light used in colorimeter is tungsten filament. Okay, next one is monochromator. To select the particular wavelength, filter or monochromators are used to split the light from the light source. And third one is a sample holder. Sample holder means the sample will be taken in a covered or test tube or some other things only. So test tube or covers are used to hold the color solution. They are made up of glass at the visible wavelength. So normally the test tube or cover should be in the glass type only. Don't use the plastic types and all. Okay. Next is photo detector system. When light falls on the detector system, an electric current is generated. This reflects in the galvanometer. Galvanometer always deflects the needle with a difference between the higher voltage to the lower voltage. Next, see the measuring device. The current from the detector is fed to the measuring device. The galvanometer shows the reading that is directly proportional to the intensity of the light. See, this is the basic diagram for the parts of the colorimeter. See, this is the basic part. A light source, it is fall between the slit. Slit means a gap between the two slides, and from that it moves to the lens. From the lens to the colored filter, colored glass filter. From there it goes to the cell for sample, and then move to the photoelectric cell. The photoelectric cell is go to the connected with the galvanometer. Okay, this galvanometer measures the photoelectric cell, which means the deflections between the electrical signal is measured by the galvanometer. Okay, see the second part of the diagram, parts of the colorimeter, a light source, a slit or photochromatic light. Photochromatic means a single form of light only emitted from the place after the slit. And then one lens part is connected. After the lens, a light is fall on the monochromatic light. Then a test tube or cover will be placed in that place. In the test tube, a liquid format will be present in that. This liquid is maybe a color reagent, which is a sample to measure by using the colorimeter technique. After that, photocell. Photocell means we know the principles of photocell. Whenever light energy falls on this plate, and electrical energy will be generated by the photocell. This is the basic principle of photocell. After that, this electrical energy is moved to the galvanometer, which will be the needle deflection will be show the how much it is deflected, and the value will be shown by the using the needle. This is the basic setup of flow representation of colorimeter. Okay, one is schematic diagram for photocolorimetry, and another one is the parts of the colorimeter setup. Next one is a working principle. See the working principle only we can see using this diagram also. From the light, the rays it will be moved to the slit. After that it moves to the lens. After the lens, the rays will be fall on the monochromator. The monochromator one side will be covered with the mercury, and another is flat. So it will be moved to the outside of the monochromator. The light will be falls on the covered. After that it will move to the photocell, then go to the output of the galvanometers. Okay, then applications of colorimeter. Colorimeters are widely used to monitor the growth of a bacterial or yeast culture. These are all done in the biochemistry lab, microbiology lab. Normally they are do as a culture test and all that. Okay. Next to applications, they are used to measure and monitor the color in various foods and beverages, including vegetable products and sugar. Certain colorimeters can measure the color that are used in copy machines. Copy machine means Xerox copy machines, fax machines, and printers. And third is colorimeters have many practical applications such as testing water quality by screening chemicals such as chlorine, fluoride, cyanide, dissolved oxygen, iron, molybdenum, zinc, and hydrogen. They are also used to determine the concentration of plant nutrients such as ammonia, nitrate, and phosphorus in soil or hemoglobin in blood. Colorimeter is also used in color printing, textile manufacturing, and paint manufacturing for precise quality inspection. These are the applications used by the calorimeters. Okay, so these are the topics which we have discussed till now. Okay, okay, thank you.